Hello everybody, my name is Landon and today we are going to be going over the plenum chamber test CAD where we will describe how to use Onshape in relation to a decently complex rocketry part in Onshape. Start off by opening Onshape and create a new document. Go ahead and name it the plenum chamber test. Create the document and it will load your workspace. Notice here we have our three planes which define our origin. This is where we will be doing our sketches. Go ahead and create a new sketch on the front plane. Click the Sketch button or Shift S and select the plane which you would like to sketch on. Let's start off by creating a center line. Go ahead and click Line, click Construction or Q, and draw a center line on your horizontal axis. Let's take a look at the drawing for the part that we want to make. Over here, we can see a couple of the parameters that we are defining our section view as. We've got length of the boss here. We've got length of this stuff. We've got O-ring specifications. We have lots of different things that define the part. And if we input each and every one of these numbers into our sketch, when we revolve it, it should look exactly like the part. Let's go ahead and start drawing our sketch. I like to start drawing by just freehanding it. I think, ooh, this looks like this goes here. Numbers don't matter right now. Just make sure you're not defining anything. Remember, if you see that a yellow thing is highlighted, it means it's doing a reference to that dimension. Let's go ahead and make sure it's not defined by anything. Great. Let's go ahead and make these 2 points coincident. Very good. That kind of looks like our part, but it doesn't have any numbers yet. Let's start off by defining some of the ones that we do know. Let's go ahead and take a look at our drawing and notice that it says 0.96 inches for this boss here. Go ahead and click on Dimension, click this line, and define it. Do the same for the rest of your part. Great. Now that we have all of the section view numbers on here, let's go ahead and take a look at the other view. Let's define the diameters using this view here and this detailed view here. Take a look at your O-ring groove diameters. Click on the center line to bring down the diameter instead of just doing the radius. Continue for the rest of the view. Notice that this diameter up here is defined by this Nom is short for nominal, which means the outer diameter does not need to be machined and can be bought at a 2.75-inch diameter stock. This diameter is defined by the other drawing. Let's go over, open the other drawing, and notice that it's 1.88 inches. Perfect. What else here is not defined? Well, if we zoom in, the depth of this will be defined by our depth of counterbore here at 0.063 inches. Another thing that's not defined yet is this diameter here. This is a little bit more complex. In the drawing, it shows us that this hole is a 45/64 drill. That makes sense to make this a 45/64 drill. But if we do it like that, and then we use the hole feature in Onshape to tap it, it will be undefined. Therefore, let's just make it 1/2 of an inch so it has material to take away. Notice that even if we make this bigger, it won't change any other variable. Therefore, this diameter is pretty arbitrary as long as it's less than 45/64. What else here is undefined? Well, notice how we can move the entire thing? Let's just make one of the points aligned with the origin. Wonderful. Now everything is solid and the lines are black, which means everything is defined. Go ahead and click Revolve or Shift W and select the sketch that you would like to revolve. Click on the revolution axis and the axis that you would like to revolve around. Confirm the revolution, and you have yourself a solid part. Very good. Let's go ahead and create a sketch for all of the holes that we noticed around the part, as well as this other odd hole up here, and let's tap the center. Go ahead and create a sketch on the top face. First of all, let's create a circle that we will bind all of the other circles to. Let's dimension this to our bolt hole diameter, which we saw in our drawing as 2.442 inches. Let's make this circle construction so we don't extrude it. Let's go ahead and draw some circles. In our drawing, it's not defined what this diameter is. It is actually just a number 10 medium clearance drill. Let's go ahead and call that 196. This is a standard and can be found in tables online. Let's go ahead and make this a solid line, and let's define it. In the drawing, there are 8 holes that are evenly spaced, which means this should be 45 degrees divided by 2. Let's go ahead and make this line as well a construction line. Go ahead and click on the circle and click Circular Pattern. There are 8 holes, and they're all equally spaced. Confirm the circular pattern. Notice how the 7 other circles are blue, which means they're not defined. Let's go ahead and confine the center of this to the origin. Perfect. Everything is fully constrained. This other circle that we had in our drawing was centered by the origin and was some diameter. Let's go take a look. This diameter was 33/64 and is positioned 1.41 inches vertically. Let's go define that. Wonderful. You may be wondering why I'm doing all of these circles on the same drawing. That's because they're all through holes, which means it'll pass all the way through the part, removing material as it goes. Let's go ahead and confirm this now that everything is fully constrained. And let's make an extrude feature. We're going to extrude this sketch by removing the material through all. If we confirm this, we notice that our part looks a lot like what we were given in the drawing. There's one more feature to do, and that's this tapped hole. Go ahead and click on the hole feature and let's use the sketch 2 as our origin for the tap. Now we are tapping all the way through the part using a tapered pipe tap, also known as a national pipe thread, and a half 14 TPI. Make sure to tap through all. Confirm, and you have just completed your first rocketry part. Congratulations.